Hey, good morning, everybody. Week 3 starting today. So we're going to wrap up the second unit by starting to look at the final study guide. Unit 2 test study guide. Now, we didn't do this for the first unit, and having seen some of the scores from the first unit test, I'm kind of wishing that we had, because there's some of the basic stuff involving definitions and things like that people have been consistently getting incorrect. So I'm hoping that we spend a little bit of time today working through this study guide together. That will improve your test scores for the second unit test, which again, that'll be released tomorrow morning. So if you've got this handout, if you're looking at it at home, I hope. That's a little bit too big. The first part of this deals with parallel and perpendicular lines, and then it quickly gets into angle relationships. In fact, that's another area where some people really need to pay close attention, because don't get vertical angles mixed up with alternate interior angles, for instance. Totally different situation. And I did see some of that on that first unit test. Because when we get two lines that cross, that's where you get the vertical angles. It's not alternate interior or any of that stuff. So it seems like there's a little bit of confusion about that. So if you look at this first shape here, it's funny looking 5-sided shape. What do we have to have for a plane that's parallel to WXT? Well, there's only one plane in this drawing that's going to be parallel to it. Think about in the room that you're in. If you're in a room right now, the ceiling and the floor, those are parallel planes. This first plane, WXT, could have been called WST, TSX, XSW. Could have been called by any 3-letter combination. Looks like somebody has an idea here. Okay, that's a good try, but that's one of the multitude of names that you could give for this first plane, this front. This is the part that's facing you here. WST, WXT, any 3 of those 4 letters identifies the plane. If you think about this shape having a top and a bottom, the top is SVUT, the bottom is WZYX. Remember those dashed lines, those dotted lines? That's the part of the shape that you can't see. If it was a solid, those would be the sides that are behind or not visible from the angle that you're viewing. So there's only one parallel plane to WXT. Anybody else want to take a crack at it? Yeah, I got one person in the room today, so let's turn the lights off and see the screen a little bit better. Yeah, the plane is parallel is VUY or VZY or YZU. Any three letters. Remember, 3 letters to identify a plane, only 2 letters to identify a line or segment. Segments parallel to VU, well, those are the vertical ones. UY, SW. You're going to go around and see that sort of question. So you have to be comfortable with interpreting those shapes. The harder questions here are number 4 and 5. Skew. Anybody remember what skew is? When we have skew lines. Not on the same plane. They don't intersect. They're not on the same line. They're going completely different directions. There's always going to be many, many more skew lines or segments than there are parallel. Okay, parallel is just got to be in the same plane. Skew, how about a segment that's skewed to segment XY?
VS.
Good, that's a good one. No, not UT. UT, I think, is parallel. What about SW? Yeah. SW, VZ, ZW, VU, let's see, ST. So how many is that so far? 5 or 6? There's plenty to choose from. So if you're asked about skew lines, you know, maybe the question will say, which of the following are skewed to some segment? That's what you're looking for, is lines that are not in the same plane. They don't intersect. They're going completely different directions. Does anybody have questions about that? Segments, planes being parallel or skew segments? And you see here, even on the filled in part, the teacher's thing here, they've listed 5 skew segments in number 4 and 4 segments for number 5. And look at how these other answers are being written. ST, ZY, WX, 2 letters. Don't forget that. That's the protocol. 2 letters for a segment, 3 letters for a plane. Questions, anybody? The next 5 problems. Name each pair of angles as corresponding: alternate interior, alternate exterior, consecutive interior, or no relationship. Identify the transversal that connects each angle pair. Well, what's the transversal for the first one? That's where you got to start. Audrey says no relationship, but that doesn't really answer my question. I'm asking about the transversal that connects the angles, if any. Angles 4 and 10. Are they on the same transversal?
Yeah. Oh.
Because that's where you have to start. If you don't know what the transversal is, remember the transversal? Anybody remember the definition? It's simply a line that intersects 2 other lines. That should be in your notes somewhere. So in this particular drawing, we've got 4 different lines. They're all labeled J, K, L, and M. Any one of them could be a transversal. So what transversal are angles 4 and 10 on?
K.
K. Yes. Thank you. I don't know who said that, but good job. So once you understand which transversal they're on, you can ignore the rest of the drawing. We don't care about anything that's on line J right now. All we care about are the angles on line K to look at the relationship between angles 4 and 10. Are they corresponding? Nope. Are they alternate interior? Well, they're on the interior of the 2 other lines, but they're not alternate. They're not on opposite sides of the transversal. Are they alternate exterior? Well, no, I just identified the interior here as the area between lines L and M. 4 and 10 are inside that area. They're not on the exterior. Are they consecutive interior angles? Okay, well, if you don't know the answer to that, you're going to need to go back and review the definitions on all of those angle relationships, because it's very specific. Consecutive interior angles. If you took your finger and start where the letter K is and you just follow that transversal down the line from right to left, and you hit one angle right after the other, that means they're consecutive. It's like counting 4, 5, 6, 7. Those are consecutive numbers. Well, here the consecutive angles are 4 and 10 and 3 and 9. They're between the other 2 lines. That's interior. They're on the same side of the transversal. Questions on that? Now, I know that the instructions for this group of problems tells you to identify the transversal last, but I would recommend that you identify it first. Once you know which angles they're talking about, like number 7 says angle 8 and angle 11. What transversal are those lines on, or those angles on? What's the letter for that transversal that those 2 angles are on? Don't be bashful now. Somebody can look at this and tell me the answer. Put it in the chat if you don't want to speak up.
Is it M?
Yeah, absolutely. So now that you've identified the transversal, are those 2 angles on the same transversal? Yes, they are. So once you know that you know the transversal, you've identified the fact that they're both on the same transversal, now you can look and see what relationship they are in, if any. Where do you go next? Well, they're not interior, right? They're not between J and K. They're exterior. Are they alternate exterior? Every one of you should be jumping up and down saying, yes, they are, Mr. Alley, Mr. J. They are alternate exterior. Remember, well, maybe you weren't here that day, but the 2 lines that the transversal cuts through, the space in between those 2 lines is what's considered the interior. It's not a closed shape, because we don't care about this other transversal over here. but it is between the two lines. There's space in there. Geometry is all about space. That space between the two lines, that's the interior of the shape. The exterior is all the space above this line and all the space below the other line. The alternate part means, are they on opposite sides of the transversal? Questions, anybody? What about number 8, angles 2 and 12? What transversal are they on?
Okay.
Yep. What's the relationship between those two?
It's an interior.
No, the interior is in here. The interior is 3, 4, 9, and 10
Oh,
between these two lines. The exterior in this case on transversal K is out here to the left and out here to the right. You know, turn this thing into a checklist. If you've got the definitions there in your notes, just ask yourself, are they corresponding? Nope. That means they got to be on the same side of the transversal, the same relative position to the lines. Are they alternate interior or consecutive interior? No, they can't be, because they're not inside the other two lines. They're not in that space that's between. So the only possibility in terms of defining the relationship that you have left is alternate exterior. Well, that doesn't work either, because they're on the same side of the transversal. They're not alternate. Alternate means you got one on one side and one on the other side of the transversal. So 2 and 12 have no relationship. And that's okay. We don't have to force something on this. Not all angles in a shape like this are going to have a relationship. So for sure, make your notes as clear as possible on these definitions, because they are going to be essential, in fact, critical, to be able to identify angle measures once we start getting into parallel lines and transversals. Anybody have questions about any of those definitions? All right, I presume everybody knows them then. And problem number 11 gets right into it. Starts off with an if-then statement. If P is parallel to Q, okay, P and Q are parallel, and angle 7 is 131 degrees. Where's angle 7? Okay, that's down here. That's across from angle 1. Okay, this line here, P, is parallel to line Q. At least now I know where angle 7 is, and I have the angle measurement for that. Angle 16 is 88 degrees. That's down here, across from angle 10. So the problem setup has given you one angle measurement on each transversal, Because what are the transversals in this example? Which lines are cutting through two other lines?
S and R.
S and R. Excellent. Very good, Jonathan. That's absolutely right. And the reason that that's key is because if we're looking for angle measurements starting with angle 7, then we only care about the angles that are on this transversal R. Because what do we got here? What's the relationship between 1 and 7?
They're the same angle.
Yeah, it's the same angle, but it's a specific name. It's a vertical angle. That's a vertical angle pair. So 1 is the same as 131 because that's what angle 7 is. And again, this goes back to your original definitions here from the first day. You can't lose that stuff. You need to keep that handy when you're doing these kind of problems. Go back and look at those drawings. Isolate the part that's supposed to be, you're supposed to be looking at here. Right now, if you just concentrate on this intersection here where 1, 2, 7, and 8 are, you can find all 4 of those angle measures just because you know that angle 7 is 131. How much is angle 2?
88 degrees.
Nope. Nope. 1 and 2 are a linear pair, right? They form a straight line. You put 1 and 2 together, you got a straight line. 7 and 8 are a linear pair. If 1 and 7 are 131, then 2 and 8 are both 49 because they have to equal 180. This is another original definition from day one. Linear pair, 2 adjacent angles that equal 180 degrees. So now to find what 3, 4, 5, and 6 are, now we have to start looking at corresponding, alternate interior, alternate exterior, consecutive interior, blah, blah, blah. Those are the add-on definitions that are going to allow us to find all the rest of those angle measurements on the transversal R. I don't even care about transversal S yet until I get everything identified on that transversal R. So which angles look, before you even worry about the definitions, which angles look like 1 and 7?
3 and 5.
Yeah, 3 and 5. In fact, from the definitions here, 3 and 1 are corresponding, right? They're below these lines. They're the left side of the transversal. 5 and 7 are corresponding. So those are both 131. And if those are 131, then 4 and 6 are both 49. And I did that subtraction in my head, so I hope it's correct. Yes, it is. Good.
It is.
180 minus 131. And if you look at this table here at the bottom of the screen, you see all these repetitive numbers here. If you're working on this handout at home, you should be filling in these numbers. So all of that we just talked about is enough to take care of every angle that's on transversal R. And all we started with was 131 degrees for angle 7. For transversal S, you can do exactly the same thing. Angle 16, 88. So 10 is 88. 14 is 88 because these are corresponding. 16 and 10 are vertical angles. Now 14 and 16 are corresponding. 14 and 12 are vertical angles. So those are all 12, 14, 10, 12, 14, 16. All are 88 degrees. Then the others are going to be the difference between 88 and 180, because those are linear pair. Questions so far? Okay, here's a tougher one. Angle A is parallel to B. Excuse me, line A is parallel to line B. Looks like they're parallel, they're flat, that's good. Angle 2 is 63 degrees. Angle 9 is 105. Find the measure of each angle. So I'm going to pause the recording here for just 1 second for you guys to think about that. So we've taken this problem number 12 now out of the study guide for the test, and we've applied a whole bunch of different definitions, and we've come up with all of the different angle measurements. I know my scribbling over here with the circles and all that stuff, and the lines that connect the different relationship pairs. You know, I made a couple of notes over here, 7 and 8 on this transversal C or linear pair. 6 and 10 are corresponding. Over here on the other transversal, 13 and 4 are corresponding. 1 and 11 are corresponding. We got vertical angles here. We got vertical angles all over the place. Remember, vertical angle definition can be one of the most helpful things that you come across here, because anytime two lines cross, the angles that are opposite each other, up and down, left and right, they're always going to be congruent. They come in pairs. They're congruent. The other thing that you can rely on absolutely is this idea of linear pair. 11 and 12 create that straight line B. 13 and 14 create the straight line B. So you can look at those totaling 180. So if you know what one of the angle measures is, you can find the other by subtracting it from 180. But none of this is possible if you don't know the definitions. And this only applies when we have parallel lines. Corresponding is the definition, but because we have parallel lines, now it adds the fact that they're congruent. All these definitions are like that with the exception of one. Alternate interior or congruent. This was on another one of the handout sheets earlier in this unit. That's why I've been stressing the importance of these definitions, because now when we start looking at parallel lines, we have some extra things that we can rely on that's going to help us with angle measurements. The fourth one, the one that's not giving us a congruency, is consecutive interior. And I'm going to add supplemental in here in case you forgot that supplemental means 180. And I still can't type, can't spell. There we go. Consecutive interior is 180. So if you're not sure about that, if we look here at angles 4 and 12, they're on the same side of the transversal. Inside lines A and D, that's that space that's defined by A and D. So how much are 4 and 12 if we put those together? Well, 4 is 42 degrees, 12 is 138. I'm pretty sure that equals 180. So you got to know these definitions. You got to know these angle relationships. If you do, you'll do great on this Unit 2 test. Anybody got questions? All right, well, let's go back to the handout again. Now, I don't know if anybody had a chance to do any practice with these kind of questions where they've got some expressions where algebra is involved. But this is just a different way to present the same kind of problem to you. So for these questions, it says, find the values of X and Y if lines L and M are parallel. How would you approach? Anybody have any ideas on how to go solve problem number 13?
This is the one I have the most problem on.
Okay. Can we create an equation to figure out what X is?
Slope intercept form.
Nah. Slope intercept has X and Y in it. We don't care about the slope. The slope intercept is not a solvable equation anyway because it's got two variables. That's not going to help us. We need to create an equation where we can either find X or we can find Y. So this is all about the definitions that we just talked about, guys. These are the parallel lines, right? L and M are parallel. This vertical line here, this angled vertical line, is your transversal. So I see two expressions here for X that have an X in them. One up here and one down here. What's the relationship between those two angles? Again, go back to your checklist. Are they consecutive?
Alternating.
Alternate what?
Exteriors.
Alternate exterior angles are congruent. So you can create an equation. Somebody read those for me. 10x
Minus 17.
10x minus 17. I lost my
8x.
whiteboard. There we go. 10x minus 17
And 8x plus 1.
equals 8x plus 1. How do I know that?
Because they're congruent.
Alternate exterior. And alternate exterior angles are congruent when we have parallel lines. So once you have this set up, now you can solve for X because now we just got a regular old single variable. I mean, it's a multi-step algebraic equation, but that's no big deal. I'm going to subtract 8x from both sides. And that's going to leave me with 2x minus 17 equals 1. Now I need to add 17 to get the x, start to get the x by itself. Leaves me with 2x equals 18, x equal 9. Okay, now what do I do with that? Now you need to look at the next problem. It's this section right here. We know what x is, so we can figure out what that angle is, 8x plus 1, right? We know x is 9. So 8 times 9 is 72, plus 1 is 73. So now, how can we figure out what y is? Are they equal?
No. Yes.
Think of the relationship again. What's the relationship now between these two angles along that line M? Nobody know? I'll go back to your sheet from day one. Six y plus 29, 8x plus 1. Okay. And again, I know what x is now, so I can replace it. What's the relationship between those two angles on that line? Got one suggestion that they're equal. Well, to be equal, they have to be either corresponding, alternate interior, or alternate exterior. Those are the only three combinations, only three angle relationships that give you congruency. So what is this called? What is that angle relationship called? Here, I'll fix this so it looks more like the drawing. The drawing that we have my angle's kind of going like that.
This straight angle.
The two angles create a straight angle, correct? So what's that called?
Is it a supplementary angle?
They are supplementary, but why? How do we know that?
Because they add up to 180.
Because what? I'm sorry.
They equal 180.
Yeah, but what's that called? What's this called? This is another definition. I've used it a bunch of times already today. It's a linear pair, guys. Come on. Linear pair. Linear pair. And they are supplementary. Everything else that you said is absolutely correct. Supplementary. Equal 180. So they don't equal each other. They do not equal each other. But if we add them together, they're going to equal 180. We can't do these kind of problems if you don't remember what a vertical angle means and what linear pair looks like. These are drawings that you need to burn into your brain. Go back, and they're all in that the very first thing that we did in this term, the first day definitions. You should have every one of those filled out with the correct definition and with the drawing. If you don't remember that stuff, go back and look at the first day video because we covered all that. I'm telling you, you need that for this unit test. To do well on this test, you can't do some of these problems without remembering this stuff. So now we got a single variable equation. We can solve for y easily. Questions on how I came up with that equation? All right. And all of these problems on that page of the study guide are the same. 13, 14, 15, they're all the same. They're all about defining the angle relationships and using those definitions to help you set up equations. For instance, the next one, we got a y, an expression here with y, we got an expression here with x, we got another expression with x. So what are we going to try to find first? What are we going to try to solve first? We're going to try to find the x first because we need to create a one variable equation that allows us to solve for the variable. So in this situation, what's the relationship between this expression 7x minus 30 and this other expression 5x plus 14? Come on, get your checklist out. Help me out here. Are they alternate interior? Everybody should be saying no.
Coordinating exterior.
Corresponding.
Corresponding.
Corresponding. And what does it mean when we have corresponding angles? It means they're congruent. They even look the same. Look at the shape here of this angle where the 5x plus 14 is. And look at the shape of this one, 7x minus 30. Those are both obtuse angles and they look exactly the same. So now your equation is 7x minus 30 equals 5x plus 15. How do I know that? Because corresponding angles are congruent. Corresponding angles are congruent. Right here on the Jamboard. Corresponding angles are congruent. I can't stress this enough, you guys. You got to know these definitions. These are the only way you're going to be able to solve those problems. So you got to identify the angle relationship first before you can even begin to set up a problem. Questions, anybody? Now, number 16 here is the first time we really get into talking about proving anything very much. So if we're going to prove that some lines are parallel, we're going to start off by looking at the angle relationships. And the definitions that we've just been talking about are how you're going to know. if they are parallel or not. So where's angle 8 and angle 20? 8's here, 20 is here. So if angle 8 and 20 are congruent, that means that they are alternate interior and the lines that are parallel are X and Z. I don't care about line Y right now because angle 8's not on that. Neither is angle 20. Again, blank that out of your mind. Ignore it. And all of these kind of problems, all these situations in here all come back to those same definitions. Angle 1 and angle 9. Angle 9. Okay, that one's on X. This one's on Y. They would be congruent and those lines would be parallel if angle 1, and it says that they're congruent. Angle 1 is congruent to angle 9. So good. They're corresponding. Corresponding angles are congruent. So angle or line X and line Y are parallel. Angle 3 and angle 10 equal 180. 3 and 10 on X and Y. What would the relationship here be for 3 and 10 if together they equal 180? Which definition would we use? Guys, you can't do this just by trying to remember all this stuff. You should be writing this down as we're talking about it. Consecutive interior. Consecutive interior equals 180. Are angles 3 and 10, are they consecutive interior?
Yes.
Yeah, they're on the same side of the transversal. Just follow that line down. Line M is the transversal. They're right next to each other on the same side, so they are consecutive. Again, it all goes back to those definitions. (17) and 18 are variations on the same theme. If we're going to prove that lines J and K are parallel to each other, there's only one value for X that would allow that to be true. So what equation do we set up here? What's the relationship here between 14x minus 25 and 129 degrees?
14x minus 25 equals 129.
Now you got it, Jonathan. Absolutely right. Because those are alternate interior, they're between the J and K lines in that space, they're going to be congruent. So then all you got to do is solve, set up that equation, solve for X, and you've got your answer that's going to prove J and K are parallel. Same kind of thing here, but it's a different definition on number 18. That one's like the last one that we talked about up here, totaling 180, because now in problem 18, these are consecutive. These are on the same side of the transversal, one right after the other, consecutive. And we are just about out of time. So thank you guys for participating today. It's been good. The last thing to really talk about here deals with slope and then writing equations. So you want to be sure you go back and know your formulas. Slope formula where you can calculate the slope, the change in y over the change in x. Know what the slope intercept form is, standard form, point slope. We didn't do too much of point slope, but it's helpful when you have a point and you have the slope. Be sure you know these definitions The slopes are the same, the lines are parallel. And remember, negative reciprocal, that two-part definition for perpendicular. You can see that from the 19 through 21, you've got some problems there where all they're doing is comparing slope. And if they meet the definition, you know if they're parallel. Remember this symbol, parallel? What about this symbol, that upside down capital T? Perpendicular. Geometry is full of graphics like that. Be sure you remember what that means. From there, it's just a matter of being able to write equations. Some of you guys have been doing really well with that on the most recent homework assignment. What do you need to write an equation? You need the slope, which is M, and we need the y-intercept, which is B. And we can use the slope-intercept form, or if you look at what's going on here, they're using point slope in every one of these situations. Sometimes you got to do the extra calculation for the slope first, but point slope can be converted to slope intercept if you just solve for y in the end. So you're going to have a few days to do the next test. It doesn't come out until tomorrow. So if you want to continue to work on this study guide, if you got questions about anything, don't rush into the test. You'll have several days to finish it. Send me a text, send me a photo of a problem that you're struggling with, and I should be able to help you. Any questions, anybody? All right, I'm going to stop the recording and let you guys go, and we'll see everybody on Thursday.